Hello, so I'm making this video to make the people understand the basic implementation of RAG, how actually RAG works. Okay, so why do we need RAG? First, we have to understand this. So the very first and basic thing is that we already know that there is OpenAI, there is Claude, and there are a lot of models. Okay, we use them, we input them some prompt or query, and then it gives some output. That is called generative AI because it is generating some output. Okay, now we come down how this is not much useful for us because already in AI models they have been already trained on some data. Okay, and the problem is that suppose if we are having some of our own context, if we have some our own work, for example like some office data or any other personal data or any other thing which we require the AI to understand, but AI is trained on some public data. It is not aware about the internal office documents or internal knowledge of some particular organization. Then what we do is that I'm just telling you the surface level. We make a box or I'll tell you what does it actually mean, and we fill all this data here. Okay, and then what we do is we provide it as a context to the LLM, and then it generates some output and which is exactly relevant to our context. Okay, now I'll tell you what I mean when I say we fill this data in a box. This box is actually a vector database. Okay, so now from here we will start. Okay, so the first thing what we do is we have some query, some requirement. Okay, what we do is we input into it, and then what we have to do is that instead of directly giving it to the LLM to get some output which is actually generative AI, we implement RAG. RAG is Retrieval Augmented Generation. Now, as the name itself explains, you can see retrieval means that we are acquiring something, we are retrieving something, and augmented means enhanced, means the outputs are actually enhanced or provided or have more relevant and more accurate information about our context, means relevant to the current context. Okay, so how do we do that? So for this we have to implement RAG. Now the basic structure of RAG is that what we do is we have some documents. For example, we might be having some PDF, we might be having some PowerPoint document, we might be having some other Excel format document, any other documents of any type. We can say it is like unarranged data or unstructured data. Okay, unstructured data, by unstructured data means data in any format which is like easy to understand by humans but not very useful for LLM. So what we have to do, we have to convert this into structured data. Okay, structured data implies data present in some proper correct format. It can be a JSON format, it can be tune format, okay, or some tabular format, so that it becomes more easy for the LLMs to understand it and then use it for giving outputs. So for this, what we do, we have to implement a data ingestion pipeline. Now what is this heavy word, data ingestion pipeline? Okay, so for this what we do is that we have some documents which is basically unstructured data. Okay, and what we do is it may be PDF, it may be docs format, it may be PPTX format, Excel format, any format. what we do is that we implement, not just implement, first we have to make it, first of all that we have to convert it. Okay, so for example we can say we start the conversion process. I am trying to keep it very simple. Okay, so as a first step of the conversion process, what we do is that we parse this data. Parse means we actually make it easy for the pipeline to understand this unstructured data. Okay, so what we do is that suppose there is a lot of text written, so we make the machine read all this data and we convert it into smaller, you can say smaller blocks, or we can say we convert it into some blocks, small blocks, and we call those blocks called chunks. Okay, so the idea behind the blocks called chunks that contain smaller or some small blocks of the unstructured data is that you use the chat interfaces. Okay, here is the audio feature, you input the text and do apply it. So what do we do is that we input the data, and sometimes the data gets too much overwhelming. Okay, overwhelming means that it is too much for one time, so that there is always a limit for the AI model to understand some particular data and then provide some output on it. There is a relevant context, there has to be some limit. Okay, so we try to reduce the size of the data. This is what we do. So we apply chunking. Chunking is a method of breaking the entire document data into small data blocks. And for this, what we do, we use some chunking techniques. Okay, so basically there are ways to do this. Okay, I'll talk about this in a specific later video. I'm just over explaining the related context. Okay, like what we are actually doing, we are breaking the big data into small blocks. Okay, then what we do, we feed it to some embedding model. Now I'll come to what is embedding. Don't worry about that. Okay, so what is meant by embedding model? So first of all, we have to understand that suppose whenever I write my name is Udit. Okay, so the computer does not understand this. Computer understands only 0, 1, these type of digits. So what we do, we convert our entire data, or we can say that whatever we are writing or we need, it is converted into numerical token format. Okay, for example, it may be in the format of -0.112896 -0.11. This is how chunking. After doing chunking, what we do embedding. For that we use some embedding model, and what it does, it converts the data into this format. The format is in numerical token form, and this is easy for us to store. Okay, so what we do, we convert the data, we convert unstructured data into chunks. Chunks are the small blocks of data. Then what we do, we have to store this. Okay, so we convert them into embeddings. And what are embeddings? Embeddings are the numerical representation of our text, and then we store. For converting them into embeddings, we use an embedding model. Embedding model is like some software or anything that converts data into embeddings. Okay, and how? So the thing here is, it may be a Gemini embedding model, or any other NVIDIA embedding models are also there. There are some open source, there are some free, there are some paid models. Okay, and then we store them in vector database, the block that I was talking about. Okay, so now what is happening? The unstructured data is now converted into structured format and stored in vector database, and this is called the data ingestion pipeline. Now what we do here is that, now if you will input some text, you provide some input, you are doing some query, this query goes to your vector database. And now here comes one more thing into scenario, like we convert our queries also into embeddings while we are, this is called retrieval pipeline. This I am telling is called retrieval pipeline. What we have to understand is that we are converting our query into embeddings. So this also gets converted into numerical format, and then this is also in some numerical format. So now we find out some semantic relation. This happens using semantic search or some other, that there are more techniques for this. What we do is that whatever we are providing as input, we just match the sentiment or the emotion, or how much it matches with the particular data stored in the vector database. So suppose you input your query, and a query means something minus 0.112. Then what we do is that in the vector database there is a lot of data stored in structured format. Then we try to match that, which top results match this. For example, 0.111, 0.110. So these two are the closest, and there might be 0.253. This is the farthest. So now what happens is that for this particular query, this particular data is relevant and it provides the context. So what we do, we retrieve this particular structured data and this was the query that was converted into embedding format, and we matched the most relevant and most semantically equivalent data, and then it goes into LLM along with the prompt. We have some prompt also for this. This prompt is used to tell to the LLM that, hello LLM, please use this relevant context to give us some output. So this is how RAG works. So now what is the benefit here? We don't need to train the data. Not required. We do not need to train the LLM using the data. Training is not required. Okay. And if we will change the database, the embeddings and the stored in vector database also gets changed, and therefore we can modify, or we can make the LLM work the way as we want, and we can change its context as frequently as possible. So that's how RAG works. Okay, now I will demonstrate this using the diagram also. You have some query. Your query is converted into embeddings and then it is matched semantically to the relevant data in the vector database this 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 now we apply some semantic search on the vector database. We retrieve the context, then based on the retrieved context plus prompt instructs the LLM to use particular relevant context fetched or retrieved context to provide some output. This is how our RAG application works, and this is traditional RAG. Now in the upcoming videos, I will make a separate video regarding chunking, and then there will be a third video which will be regarding embeddings. I'll talk about embeddings, and in the fourth video I'll talk about the data ingestion pipeline, how to implement it practically. And in the fourth I will tell you about the retrieval pipeline and how to implement it practically. Okay, bye.